So now, I figured I would do a step-by-step build of the Astable mode 555 timer, and it's going to alternate the LEDs. Main thing though is it keeps alternating the output high and low, and this is the NE555. There you can see that right there. It says P at the end right there. Main thing is NE555. If it says micro A UA 555, that will work the same right there. Other 555 timers will have different letters in front of them, and they may have different electrical properties that you got to be aware of. Make sure you check the data sheet. But in case, there we plug it in. So this 555 timer I got from this kit right there. It shares a spot with the LM358 right there, so I got to look at the part numbers to make sure I grab the right one. But in case, when you get integrated circuits, I recommend getting kits that have the one you want plus a bunch of other ones. Now, we have to power the 555 timer. I already got that in the plug. Of course, we don't have the power supply attached yet. We're going to set it to 5 volts. That's what this one's designed for. And then when I plug in the negative there, I got that jumper coming across. So I already got them. But we got to power the 555 timer. So first we'll start with pin 1, because the divot's at the top there. Negative supply right there. And then pin 8, positive supply. Might say VCC. This might say ground. But in case, that's how you power the 555 timer. And that powers the output, the internal circuitry, and there's a voltage divider for 1/3 and 2/3 of the supply voltage to be aware of. Now, we're going to look at the output really quick. So, we got from the positive supply, 1K resistor and LED coming to the output. Order does not matter, and I'm going to use a blue LED because I like to use blue to indicate that an output is low. So, we are going to take it and put the long lead, the anode, directly to the positive supply right there instead of the resistor. And yeah, I think over there will be fine. And then we're going to protect it with a 1000 ohm resistor. Blue LEDs are pretty bright, and so we don't need much current to really get them to light up. So I'm going to come to the output and then go up there. And so yeah, you can see we got positive supply there. If you see it lit up, you know that output is headed to ground right there. Pretty straightforward. Now we're going to take a red LED, and again, instead of going directly to the output, I'm going to go directly to ground right there. And then we're going to use a resistor from the output to the LED. Doesn't matter the order right there, as long as you put the LED in the right way. So short lead, the cathode is to our negative supply there once we apply power, and it needs more current. So we're going to use a 220 ohm resistor. Also, the output doesn't connect directly to the positive supply like it does with the negative supply. It loses some voltage thanks to some transistors that it has to go through. Something to be aware of. And so that's another reason why we're using the lower value resistor. But even if it made a great connection to 5 volts, 220 ohms would be a good choice. So now, before we get to the timing part of the circuit, you notice here, pin 4 is directly to the positive supply. That's how you wire it up when it's in Astable mode. Low input, so a connection to ground right there, to the reset pin, pin number 4, will hold the output low, no matter what you do. And we don't want that. We want it to alternate high and low. So putting pin 4 to the positive supply disables that pin. So that's how you disable it when you don't want it to ever force the output low. Now, we're going to take this jumper there, go to pin 6, the threshold pin, and pin 2, the trigger pin. So it's important when you have it in Astable mode that these two pins see the same voltage because they respond to opposite ends of the voltage. While the capacitor is charging, pin 6 will sense when it gets to 2/3 of the supply voltage. And then when it's discharging, pin 2 will sense when it gets to 1/3 of the supply voltage. That's the internal voltage divider right there. So they need to see that same voltage. And it bounces back and forth. We'll get to that. So let's get to that. We have our timing resistors, and LED is optional, but or diode I mean is optional, but it's a good thing to add. And then the capacitor. And these values determine how fast it will go. So first let's go with the charging, which is when the output will be high. So 10K resistor to the positive supply. So I got 10K right there. and it's going to the discharge pin. So that's pin 7, discharge pin. When the output is high, it's like an off switch, and then when the output's low, it connects to ground right there. It kind of follows what the output is doing. And so just be aware of that. So first we're going to focus on the charging, that 10K resistor, and then a diode. So that gives us a almost direct connection from 7 to when the capacitor, when we add it. It's where that jumper is. And so I'm going to push these together. There's a little gray band. That's the cathode right there. That's where we want to connect where the capacitor will be. The side without the band will be at the discharge pin, pin 7 up there. So there we go. Hopefully you can see that. Okay, right there. And then now we will add the capacitor. We could add the resistor, but I'm going to add the capacitor. Just we're looking at this path right there. And so plug it in there. And there we go. So this is 100 microfarad. It says 100 microfarad on there. Looks like 100 and then UF. And you got to put the gray band to ground right there. Wherever it's more negative part of the circuit. And the most negative part is the ground right there. Negative supply. Now, we have a charge path. There's no way it can discharge right now. The diode prevents that. So we're charging through 10K, and to get the timing really close to equal, we want to discharge through 10K. The exact same amount of resistance, and you know, it just varies a spec because the diode makes a slight difference, but hardly any. You'll get really close to 50% duty cycle, which means the output will be high and low for about an equal amount of time. About half of the total time, the output will be high. That's what duty cycle means right there. And yeah, that's really about it. And again, while the capacitor is charging up to 2/3 supply voltage, output is high. Once it hits that point, pin 6 senses that, it tells the output to go low, and the discharge pin connects to ground. So the capacitor can discharge. So low output capacitor discharging. They're both doing kind of the same thing. Easy way to remember it there. Blue LED is going to light up when the output's low, and then red LED is going to light up when the output is high. So now there's a number of ways you can power this, but a bench power supply is pretty much the best option. And we got it set to 5 volts right there. And we just need to attach these alligator clips, other end of the banana clips there, to these header pins that I got there. So the shorter ones are pointing up, the longer ones go into the board. That's how we're going to power this. Now, I have the power supply set to 5 volts. Output is on right now. I could turn the output off, and I definitely want to do that if you're wiring it up while the power supply is attached. And then, yeah, we can just leave it off. And then I'll plug positive there. So we could have left it like that while we were wiring up. That would have been fine. You could run into troubles if you try wiring everything up while power is applied. You might short circuit or something. That's one reason why I have the maximum current set to 20 milliamps right there. But in any case, we're going to pull it down there and apply the power. You can see the power is on. LEDs are flashing. I turned the light up. And then so we got the jumpers. That blue row over there does not connect to the blue one over there. That's why I got that jumper going across. Same with the red right there for positive. But yeah, this is Astable. As long as I don't lose connection right there. It's just going to keep bouncing back and forth, as I said before. Charging up to 2/3, discharge down to 1/3. And it takes about a second or so, because a 10K resistor for charging, 100 microfarad. If we had a 1,000 microfarad capacitor, then a 1,000 ohm resistor will set about the same amount of timing. You can adjust the values as needed to get the timing that you want. Main thing is, though, use equal value resistors if you have that diode right there, so that the charge and discharge are equal. If I yank the diode, which is okay as well, the output's going to be high for about twice as long as the output's low. So you can see it's taking about the same amount of time to discharge, but now it's taking twice as long to charge about that if I don't mess up the power. This breadboard isn't the greatest. You kind of lose connections right there. I would just be setting it flat if I was just doing, you know, prototype testing like this. I wouldn't be holding it more for to show you. So, in any case, went slow with this, but it's meant for absolute beginners. that don't have much experience building circuits on breadboards. So, hope you enjoyed. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.